Well, hey there. Good morning, team. Dr. Mickey Lux coming at you, your chemistry coach. Unfortunately, we're doing remote labs this semester, so you can't check into your lockers, but welcome to your lab, right? So we would normally be, I'll kind of look down like this. We would be locking in, going into our lockers like this with all of our goodie supplies. And we would do, once, of course, we know that you're into the class for sure. We normally can't let you into a lab unless you sign all of the safety agreements and check into your lockers. So here's just something you would sign, signing into the lockers, saying, yes, I'm not going to stick a burette through my eyeball or my neighbor's eyeball, all that fun stuff. And then we're going to check all those goodies in here. And of course, in the beginning of the semester, we would go through together and check out what's in. And at the end of the semester, we would, on the last day, make sure something didn't end up in your pocket and end up home or break or something like that. So what I want to do is just kind of quickly go through and show you all the items. I figure most of you have had high school or introductory chemistry, but some of you maybe haven't had lab experience. I don't know. It's hard to say. There might be some new glassware in here. Even though we're doing remote labs, you're going to be reading through the instructions. It'll say use this, use this. So I want you to know what those items are and what we use those for. Normally I'd be wearing my goggles, but I'm not dealing with any chemicals today, right? So pretty sure I'm not going to stick a test tube in, get it in my eyeball or something like that. So what I want to do is just walk through all the fun items here like I would normally do in a semester and just explain everything, safety issues with them. So of course, what can you do without a test tube? So we've got two different types of test tubes. Obviously, small test tubes and large test tubes. Sometimes they will be stated based on their length. So I got a trusty little ruler here. Of course, we don't measure things in inches in chemistry. It's always in centimeters. So if we look at centimeters, you can see that's right around 10 centimeters long, right? So right about there. So sometimes you'll hear the small test tubes represented as 10 centimeter test tubes. And then the large test tubes, let's see how long these puppies are. Looks right around 15. So a lot of times you'll hear these as 15 centimeter test tubes as well. And so we have normally 8 of these small ones because a lot of times we're doing lots of reactions, and then 2 of these large ones or the 15 centimeter test tubes. And what you always want to do is go through, make sure they're not cracked, dirty, anything like that. Make sure there's no chips along the edge. You don't want to catch your finger on there and cut yourself or something. So we would always check that, and if anything looked chipped or cracked or broken, we would replace that on day one. I always want to make sure that your locker has everything it needs in there. There's nothing missing, nothing extra, right? It's amazing what stuff ends up. People end up grabbing their neighbor's thing at the end of the semester. Now, if we check out properly at the end of the semester, I take great care. Normally, I don't run any labs the last day except maybe some calculations that need to be cleaned up. But I make sure we go through, clean all of our glassware out on the last day, make sure everything's in there, anything extra we take out, clean everything out, replace the drawer lining, clean up around the lab, make sure everything's good. I want this place just spit polished so whatever class is using it the following semester goes, oh yeah, we got Lux's lab or something like that, right? Like having a good reputation of leaving things better than we got them. And it saves time. If we check out properly, then nobody has to waste time the next semester checking in. We just go through, everything's clean, everything's there. But if stuff is missing from 20 different lockers, I end up wasting half an hour fetching items that are missing or replacing broken stuff. So those were the 8 small test tubes and the 2 large test tubes. Next, we've got the test tube rack and the test tube holder. Of course, the test tube rack is what your test tubes are in. That's easy enough. So as we're doing this, I'll put everything back in the drawer. And test tube holder, of course, because when we're heating things, right? Let me get a large test tube. So say I needed to run this at a higher temperature. You don't want to hold it in your hand because the glass conducts heat. That would not be a good thing. So these test tubes holders are great. It's like if you're shooting, an archer, and there's regular bows and then there's compound bows. And the compound bow, when you pull, it doesn't take a lot of effort to hold it. Whereas some of the older ones, you're like, right? It's not fun. So this is nice. You don't have to continually squeeze it. You squeeze it, set it on there, and you don't have to apply any effort whatsoever. So this allows me to move it through a Bunsen burner flame, put it in, in and out of a hot water bath or something like that. So I don't burn my sensitive little fingers, right? Or if you don't want to touch it at all. So that's nice and easy for a test tube holder. let's take a look. Now we've got test tube brushes, or the two next to. We've got small and large. Obviously, if I want to clean a large test tube, I need a large test tube brush. You don't want to stick paper towels and crud down there. You can get little particles and whatnot. So we get a little, soap and water, clean that baby out real good. Of course, this wouldn't fit in a small test tube. That's why we have the small test tube ones. See that? It doesn't fit. So we have the small test tube brush for that. So pretty simple. And you always want to make a habit at the end of every lab section. I would clean out all your test tubes and beakers and rinse them out. I'll talk about using tap water versus deionized water in a little bit here. Just make sure they're all cleaned properly. And that way, when you come back the next time, any water has evaporated. We use deionized water. And it's all clean and dry. You don't have to waste any time at the beginning of the next lab dealing with that. All right, next on our list is the old watch glass, if you've never seen. This is a watch glass for that. It's nice. An experiment we did in introductory chemistry, we put two different solids on there. One was one absorbed water from the air and one released, right? So some terms you'll learn and whatnot. But you could actually watch one of them get kind of wet. And if it's deliquescent, it actually can dissolve itself. It absorbs enough water vapor from the air to dissolve itself. It's kind of cool, right? Another thing we use for this is if you want to, maybe you've got a volatile liquid or something that tends to go from a liquid to a gas phase a little more than you're happy with. You can kind of set that on there. It's not going to, stop it, but it can limit it a little bit and keep that liquid level from dropping too much. So good use for watch glasses. So we would normally, make sure it's not cracked or chipped or dirty or anything like that. Stick that back in my drawer. Next, evaporation dish. So this is not glass, it's made of ceramic. So this is a little more useful if you're heating something to a really high temperature. Pop it in there, let it go. You're not going to do a lab like this, but it's kind of fun. I put some alcohol in there. If it's at least 50 proof, it burns real nice. You can put some alcohol, light it up. That's not don't ever do non-sanctioned experiments in the laboratory, but that's a fun one for evaporation dish. Back in the old day, right? Are you proof this is at least half alcohol? Well, yeah, works out good. So take the alcohol percent and double it. That's your proof, right? So 50% alcohol would be 100 proof. All right, what's next? Getting off track there, going down the rabbit holes. Well plates. Looking at the well plates. So sometimes we'll do experiments where maybe we're not looking for really great results. We're just looking for a color change or something. And instead of using 2 milliliters of a reactant, we can just use a couple drops. So it saves a lot of money. If we've got, 500 to 1,000 students come through, that saves a lot of money on chemicals and waste, right? Reduces a lot of waste. So these well plates are useful where you can pop everything in there and look for simple color changes and whatnot. Do like little micro experiments. So well plate. What's after that? Crucible tongs. Different than your test tube holder. So these have so if your test tube holders look like this, right, for test tubes, this is for a crucible. So you see this little indentation there? A lot of times, and we'll get to crucibles in a little bit. So crucibles, again, are ceramic things that we put up and heat to quite high temperatures. You don't want to grab them, you'll burn your fingers. So what's good about these crucible tongs is you can pick up that crucible without burning your hands, right? And you can move that around and let that cool off. That's about all this is not used to grab, you're not gonna grab a test tube, that's a big no-no, okay? That's just for crucibles, all right? So let's take a look next. Now we're getting into our beakers. This is one of the mainstays here. So we've got different sizes, 600, 400, 250, 10, 100, or 150. So we have a bunch of different sizes. Now for beakers, again, make sure they're not cracked or chipped around the edges and make sure they're clean. These aren't really good measuring device. They're not made, if I fill this up to 300 milliliters here, it's probably not really 300 milliliters. These are not accurate. Think of these as chemistry pots and pans that we just do stuff in, right? So you're not going to measure things accurately at all with this. But to get the maximum size, just look for the kind of the white polygon here. You can see the 600 milliliters, the Kymax or Pyrex. You'll see different types of glass. That's not important. But this is a glass that's made where when you're heating it under a Bunsen burner flame, it's not going to deform or melt on you, right? So this is kind of the nicer Nordstrom quality glass. So we've got a 600 milliliter. And then this one, you see the white shape there. There's the 400 milliliter. And they are graduated, but they're just approximates. We've got our 250. right there. And that one, see the Pyrex on that one. We've got the either 100 or 150. So in this locker, we have 100. And the cute little 10. These are adorable. We use these in a later experiment where we're looking for proof that a chemical reaction occurred. So we're doing all these little, color changes, odor changes. And to detect an odor change, sometimes that can be hard in a test tube because the gas particles have to get out and you have to waft them to your nose. I'm not doing safety for this one, just lockers. But this has a bigger surface area, so it's easier to detect a gas, all right? So those are all our beakers. Now, it looks like these would stack in real nice. Don't do that. That's called nesting. We're not birds, all right? So I don't want you to stack and rack these because they can get stuck in each other. And I've seen people drop them in and smash that one. I've seen them get stuck. So please don't nest your beakers. You got to keep them separated, right? So just keep them separated, pop them back in your drawer, and you are good to go with your beakers. Just make sure they're all not cracked. So that's that side. Let's move up here. 250 milliliter plastic bottle and a 1 liter plastic bottle. So one thing we do, in introductory chemistry, a lot of solutions are made for you, and you just go up to the front of the lab and grab those. Whereas in Chem 180 and 185, commonly you work on your own, right? So you don't have lab partners or anything like that. So you might need to make an acid solution to titrate a base, or make a base to titrate an acid, or just some chemical that you're going to need to use quite a bit of. So what you can do, if you make 250 mils or less, you can put it in there. If you make a liter or less, you can pop it in there and just get a piece of tape, put your name on there, what's the chemical, what's its concentration, and store it up nice and tightly, right? You don't want carbon dioxide getting in there and acidifying it. Just some simple storage bottles for us. I'll pop that back in the drawer. And remember, at the end of every day, clean everything out, put it back in, lock your drawer up, because you'll probably have a calculator or something in there. You don't want people snooping in your drawers. Then we got our glass funnel. All right, and I'll do another video of how to do, filtration and things like that. But this is what we would use for filtration, where we can just fold up a filter paper, pop it in there, pour through a heterogeneous mixture. The solid gets stuck in the filter paper, the liquid or filtrate comes out, and we can collect that in some kind of beaker or flask or something like that. So it's a great use for separation technique called filtration. All right, so glass funnel. We'll pop that back in the drawer. What's after the funnel? Pinch clamps. So we got a couple of pinch clamps here. Now, pinch clamps we use for our gas law experiments later on down the road. Now, these look like some kind of torture device. Oh, ouch, that actually hurt. So don't put that on the base of your fingernail. But these are like on-off switches for allowing a gas to flow or not flow through a little plastic tube. So you're going to set up an apparatus where you generate a gas and guide it through a system that you're going to make. Or watch us make in these ones, but if we're not in a remote lab, you'd make it yourself. So if you've got this hanging from it right here, right, that's an on switch, the gas can flow. But if I squeeze this, if I squeeze it and pinch it, it pinches the tube. You see that? So that tube is pinched, so no gas is gonna flow through that. So that's off, and if I open it up and let it hang, that's on. Right? So it's just an on-off switch. We use 2 of these at 2 different points in our apparatus to allow the gas to flow or not flow. That's the key for the pinch clamps. Now we've got our Erlenmeyer flasks. So these are 250 milliliter Erlenmeyer flasks, and we should have 5 of those babies. So these are your Erlenmeyer flasks. Right? You see the 250 max. Again, not a great measuring device. It's not accurate. Really, all this is just take a beaker, heat it up, and squish it. Right? That's all it is. It's just a squished beaker. It just has a smaller entrance hole. So this is great if you want to prevent splashing or something. So we're going to do titrations later, where you're titrating, spraying a liquid down. If you have a big open beaker, it can hit and you might get some droplets to come out. You don't want that to happen. So what we use is an Erlenmeyer flask where we can spray it in there, and that smaller opening really prevents any backsplash or backsplatter. So you need 5 of these babies. So you just check them, make sure they're not chipped, make sure they're clean and not cracked anywhere in there. And we pop those back in our drawer. 1, 2, 3, 4, 5. So I'm doing checking for you. Be careful not to smash your glass, right? After our Erlenmeyer flasks are our 10 milliliter and 50 milliliter graduated cylinders. This is where we're going when we talk about, hey, if you want to measure the volume of something, these are your go-tos. Obviously, the 50 milliliter maximum there and a 10 milliliter maximum there. And the taller one has this plastic guard that moves up and down. So you usually want to keep it up above the 50 so it doesn't interfere with measurements. And it has a base. Sometimes those bases are made of are just a glass part of it there. But I like these that are removable because you can pull this off, see if it's wet or whatever. And this is in case it falls down, bump, it bounces and doesn't break. That's a key thing. The 10 milliliter, sometimes you'll see one of these plastic guards as well. Usually not a big deal, not a far way to fall. But if that's something that you want, we can always pop one on there, but typically not important. So there's going to be other videos on how to read these to the proper number of decimal places, or called the absolute uncertainty. That's going to be a real key thing in lab. Can you take any measuring device and figure out how many decimal places you can read that baby to? Super important. But that's not the point of this particular video. All right, after the graduated cylinders, we have a 500 milliliter Florence flask, aka the infamous or round bottom flask. Most people just call it, hey, go get me a round bottom flask because it has a round bottom, right? But it's a Florence flask. Obviously, there's no lines on there at all, so you couldn't measure volume in here if you wanted to. So this is just another storage container, although it doesn't have a cap like the plastic storage bottles, so you would have to get a stopper to pop in there. Let me go grab a stopper. I'm going to pause this and show you good stoppers versus bad stoppers. I'll be right back. I'm going to head to the back of the lab and go find a good stopper and a bad stopper for this. Hey, we are back. All right, so stoppers are just community supplies we keep in the back of the lab by the hood over there. And when you're looking at stoppers, you can see the number on there. I don't know if you can see the number 5 on there. And then when you go a little bit bigger, right? So this stopper's a little bit bigger. That's a number 6. Number 7. So the bigger the number, the bigger the diameter of that stopper. And some have holes in them, some don't. So I've got a number 5 solid and a number 5 with 2 holes. Well, if you're trying to store a solution in there, using one with holes wouldn't be smart because it can evaporate, CO2 can get in there, right? Oh, you're breathing on it. Now make sure you keep your finger on it and don't just drop it. Right? Don't be like, ha, 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 oh, crap, you know? You get that all the time. I've had them go plop into their solution and it's toast, and I got to go do surgery to get the stupid stopper out. So obviously, keep your finger on it and go, well, that's obviously not going to work. I see every semester people just drop it in there and go, oops, Dr. Lux, I got a problem. So number 5 was too small, right? Number 7, obviously, is too big, right? Sounds like some kind of kid story. Anyway, number 6 works good. Now, if you got a good stopper, when it's in nice and tight, it should be about half out and half in. That's a beautiful stopper. Do you see that? Half in, half out. And then when you're done with the stopper, if you're using it, obviously it's in your drawer. When you're done with it, you clean it off, dry it off, put it back in the drawer as community supplies. So that round bottom flask, it's just for storing solutions in there. Of course, you'd use some tape, put your name on there, because if you leave it out in the room and there's, most of the solutions look like water, and I don't know what it is, and there's no name on it, I got to get rid of it, and you'll have to make it all over again. That would be a bummer. So you always want to label them and check your material. Make sure it's not left out at the end of the day. All right, next is our thermometer. Now, we keep these in the drawer, so I'm going to show you this here. So I don't know if you can see the thermometer up on the side here. Do you see it? So I got a thermometer, and we keep it here. There's our thermometer at an angle. So let me pull this out, and it's Velcroed to the side. And the reason we do that, we want to keep the bulb. This has kind of a blue-colored alcohol. The best ones were the old mercury ones, but we can't use those anymore. So some kind of colored alcohol solution, usually red or blue. There's one that looks like Lakers colors. It's kind of a goldish color thing with a purple liquid. It's really cool looking. But you want to keep it with the liquid in the bulb, because if you keep it like this, sometimes it can get separated, and you'll see that in some of the videos. You always want to check this line and make sure it's a continuous line all the way down to the bottom, and it doesn't like go here and then stop and start again, and you've got these gaps in there. You don't want gaps in your thermometer. So another thing to watch out for thermometers, they have a bad habit of rolling off the table, right? That was the problem with the old mercury. Every smell, oh, there's mercury all over the floor. Bad news, so we don't do that anymore. Mercury cleanup aisle 1. So in this particular lab, if you look up here, there's a little, there's a metal rod on the outside here. So if I set it up here, it doesn't roll off, right? Which is useful. And you never want to just leave it hanging. You don't want to just have it like, I'll see people just leave it in a beaker and then they hit it and psh, it breaks and flips out. So don't leave it in the glassware and make sure it can't roll off. So my recommendation, either put it up here so it doesn't roll off, but a lot of people forget that. But when you're done with it, just pop it back in your drawer with the bulb end down and you're good as gold. So in introductory chemistry, at least here at Orange Coast College, you don't get your own thermometer. Not too critical, right? But in general chemistry, we do a lot of experiments where temperatures need to be as accurate as possible. And we're going to do a lab called calibrations, where we're going to find out, I could pass around a beaker of tap water and everybody sticks to the thermometer and we can get 15 different answers. And we're like, oh my gosh, so we need to synchronize or calibrate to make sure all the thermometers are reading correctly. And we need to keep track of that with what's called a correction factor. And what you do is you'll calculate it and just write it on a card. So this one was off by 0.1 degrees Celsius. It was always low by 0.1, so you had to add 0.1 to get to it. And you just leave this in your drawer, so that way when you take a temperature measurement, you always know to apply the correction factor because your thermometer is reading too high or too low. All right? You'll do that. The higher up you go in chemistry, especially analytical chemistry, you'll probably spend 15 minutes to a half an hour every day just calibrating all your glassware. Make sure it's reading properly. All right, DiWash Bottle. Woo, this may be one of the most important things in here because tap water, right, anything coming out of here, this tap water, that's considered dirty. That's fine at home, right? We can drink that at home, whatever. But in chemistry, we need pure water. So that tap water probably has, iron ions, calcium ions, could have bacteria in there. Who knows what metals are in contact with, hard water. So we can't use that to clean our glassware or make solutions out of because it would contaminate it because it's a mixture. Well, here we actually have one faucet, and I'll take you over to that faucet. Let's travel together. Now, in each lab, it might be in a different place, but this one, we have one faucet at the very end over here. It says DW or DI over here, and when you turn that on, that has been treated to remove all of the impurities. So that is actually pure water. That is the only thing that can go in your DI water bottle. We only want the pure water, all right? And we're going to use that to clean our glassware. So for example, let's say I did an experiment and I mixed some chemicals in here, right? I would dispose of those chemicals properly off in the hood, right? Disposal of toxic metal waste. And then what I would do is I would, get out as much as I can. And then what I'm going to do is I'm going to flush that with some tap water. All right? So I flush that with some tap water. Now at home, that'd be perfectly clean. Here, this is not clean. Looks clean, but that tap water, that's not clean. So what we'll do, and since we only have one DI water tap, I don't want the whole lab back there in line. And I've run out of DI water once because we don't want to splosh around. We only have a limited amount. Or we create it at a limited rate. So what we do is we take this at our station and we need to get rid of this layer of tap water. So what we're going to do is we're going to spray, I'm just going to spray this, twirl it around and spray it. Water can go down the sink, of course. Now one rinse probably is not, it's going to get rid of a lot of the tap water, but not all of it. And this is true, it's called conditioning. Acclimating, there's a lot of different words for it. But if we condition this, we're getting rid of the other liquid and putting a surface layer of a new liquid. So if you're going from one solution to another, water to a solution to water, if it's a different liquid, you always want to condition it. So one rinse usually isn't enough. Swirl it around, do it another time. 2 rinses, you probably got rid of 95+% of it. 3 rinses, probably pretty good, but the magic number for us to make sure it's probably 99.9999 something percent, do a 4th rinse with deionized water like that. And this is how you clean out your test tubes at the end of the day after 4 rinses, and then just put it in your drawer, let it air dry. You can clean the outside with paper towel, but you don't want to stick a paper towel in there. You want to get shards or little particles and stuff in there. So that's key. So one good, dispose of the waste properly, 1 good rinse with tap water, 4 rinses with your deionized water, and you're probably good to go. So that's why we have the DI water there. After that, we've got our glass stirring rod. So we've got our glass stirring rod, and normally it has a flat, this one doesn't, but normally it has a flatter end on one side that you can use as a plunger. So if you are mixing two chemicals and you got too much of one and the other, you can't mix it anymore. So you can use the plunger side, you know, like I just taught my 10-year-old daughter, she overflowed the toilet, so I had to teach her how to use the plunger, and she's like, wow, that was cool. So same thing, you plunge it, it allows you to mix it, right? But every time your stuff comes in contact with another surface, there's a risk of cross-contamination. So preferably you don't do that. We can also use this for decantation. When you're decanting stuff, you'll see that in the video where you pour it and the liquid sticks to the side and you can guide the liquid with your stirring rod. Hey, we're almost done. Burette reading card is next. So this we need, and that's going to be a whole nother video, right? A whole entire nother video. But when you're trying to read like a clear colorless liquid in here, we're not here to teach you how to use it, but you can put this behind it and lift this up so that the top of that black line right there is just underneath the meniscus of the liquid water, and it allows you to find that. So we're going to do that on another video where you can actually see that happen. But you need one. Sometimes you'll have two of these, not important. Just make sure you've got, it could be anything that has that black line. And at other places, some people call it a meniscus reading card. We call it a Burette reading card, but you can use it for graduated cylinders. It just allows you to find the very bottom of a meniscus of a lightly colored or clear, not clear, but colorless or lightly colored liquid inside glass, right? Can be really hard to find sometimes. So we need that Burette reading card. Wire gauze. So wire gauze we're going to use to create what's called a hot water bath. So notice we've got these ring stands here, right? So we got this ring stands, we got like clamps and stuff in here. Well, this has an iron ring that we can pop on here. And then what we can do is pop this on top of that iron ring. And then I can take maybe a beaker. I can fill that up with some water, maybe about halfway or so. I can pop that on there, and then I can take my Bunsen burner, light that up, and then I can heat this up to a specific temperature. And then if I wanted to, I could put a couple of test tubes in there, make what's called, I call it a chemical jacuzzi or a hot water bath. Let them, so maybe I got that at 75 degrees Celsius, let the chemicals sit for a while. They're not in contact with the tap water, right? And once they're there at thermal equilibrium, pull them out, mix them together, shake it up, and I just did that reaction at 75 degrees Celsius or whatever temperature you're at. Just be careful because that's probably hot. So when you turn your flame off, make sure you don't just grab it with your hand and spill it all over the place. Let it cool down to room temperature before you take that out, and then you could just dump your tap water. And this would be super hot too, so let that cool down before you grab it. Always put your hand over it to see if you feel heat emanating from it, and if you don't, give it a little tap, and you're good to go. If you just grab it, and then you get burns on your writing finger, that's no good. So that's what we use the wire gauze for, is to create hot water baths. We can do the same thing with a clay triangle. We don't have them in our drawers, but let me go grab a clay triangle for you real quick. Here's our clay triangle. We can, now sometimes they're in your drawer, sometimes they're community supplies, just depends. You can go to the same iron ring and you can just pop the clay triangle on there. And what's nice is if you're heating a crucible, it fits in there perfectly. You see that? And then I can set that up on the ring, and then I can heat that up with a Bunsen burner and then use my Crucible Tongs to pull that off when we're all done. So, and then if it's community supply, you just put it back in the drawer at the end of the day. And last but not least, we've got the crucibles with lids. Should have two of them. And so here's the crucible made of ceramic with a little lid there. And so we can put stuff in there, put it in the clay triangle, and heat that up to pretty high temperatures, which is great, right? Just make sure they're not cracked or anything like that for our two crucibles. And then we pop them in our drawer, lock our drawer up, and we're good to go. So at the end of the day, we would sign this off, and that just says, hey, we got everything in there. And again, the last day we would come in and check out, make sure everything's clean and in there and good to go. But that's your lockers, gang. Yeah.